Hello students, I hope you are good, well and fine. Today we will be continuing our discussion. Okay, so in previous classes what we discussed about functions, some basic functions, real valued, identity, constant function, polynomial, rational, the modulus and the signum function. At last we discussed the greatest integer function. It's time to discuss in today's class we will be discussing types of functions, which is one, onto and bijective, and we will be seeing the examples, okay, so that you can understand exactly what do we mean by one function, what do we mean by onto function, and what do we mean by bijective functions. So let's jump to our topic. So types of function. So one function, onto function and bijective function. So let's talk about one function. As the name suggests, one, what can anybody guess what it means? One, can anybody? So a one function, a function f from x to y. So this is my domain, okay, and what it is called? It is called as codomain, okay. So this is my domain and this is my codomain. So a function f from a set x to set y is defined to be one, or the another name for it is injective, if the images of distinct elements of x under f are distinct. What does it mean? It means when you put any two input, if you get same output from those input, this means the input must also be equal to each other, okay. If it doesn't happen, this means the function is called many one. Let's see what do we mean by all of these from picture. So this is my set x, this is my set y. So x1, x2, x3, suppose these are the elements from the domain set, and y1, y2, y3 and y4 are the elements from the codomain set, okay. First of all, it is a function, so all element must be associated to some element of y, and or every element in this set x must have what? One and only one image in the set y, okay. So just associate them like this, okay. Now like this, okay, and like this. So it satisfies all the condition to be a function, okay. So it is a function, okay, legit. Now what is it of one? Let's go by definition. So definition says if fx1 is equal to fx2. So here you can see that fx1 is y1 and fx2 is also what? Y1. So yes, indeed, y1 is equals to y1. This means fx1 is equals to fx2, okay. Does x1 equals to x2? No, as you can see, the x1 element is different to x2 element. So these are not equal to each other. This means this is not one or injective function, okay. So you can see that injective function cannot have such representation. So injective function cannot have such representation. Why? Because here this x element and this x element associated to the same element, but both are different. In injective function, the input we give and there's only one output to associated it to. So here if you see this output is associated to this input and this input. This cannot happen in one function. So this is not allowed. This is not allowed in one function. Okay, I hope that it is clear to you. So what is allowed in one function? One function allowed what? Let's see. So x1, x2, x3, y1, y2, y3, and say y3, y4. So if x1 is associated like this, x2 cannot be associated to y1 because it cannot uh, follows the condition for to be a one function. Yes. So I am going to associated it y2, and x3 is associated to y4. Now, does it follows the one condition? Yes. Why? If you see, take any two input and their outputs are not going to be the same. The output will also be the distinct. Yes, if you can see here. Or if x1, say if say a equals to f of b, if f of a is equals to f of b, here a and b I am taking from the set x. I am not naming it as x1, x2 and so on. Okay. So if you see, does this happen? F of a is equals to f of b? No, there are no elements such that the output uh, two distinct element, we do not have two distinct elements such that their output will be same. As you can see from here, if the input is x1, the output is y1. If input is x2, the output is y2. If input is x3, the output is y4. This only happens where this can happens if a is my what? X1, and b is my what? X1. As you can see, so this means a and b must be equal to each other. As you can see, if I write x1, f of x1 equals to f of x1, this is only true when this happens. That's why the thing written over here makes sense. Okay, like this. If my function is 1 then if the output is equal to each other and we arrive to this condition that x1 is equals to x2, then we can say that it is my injective function. So from pictorial representation, we can say that what we can say that my one function will be looking like this. So from here to here, the single an element from this set, the domain set, is associated to an element domain. Okay, so domain, an element to the set in the codomain set, and this condition holds that if x1 not equals to x2, as you can take any two distinct element, if x1 is not equals to x2, then fx1 cannot be equals to fx2. Yes, then fx1 cannot be equals to fx2. Okay, so pick any two different elements from the domain, you cannot have the same image, as you can see from pictorial representation. So in 1-1 diagram, this always happens. Okay, so 1-1 function. I hope that it is clear to you. What do we mean by 1-1 function? Okay. If it is not 1-1, then it might be many one, as the name suggests. As you can see, 1-1. So here the one element is only associated to one element over here, and these are not like many one. In many one you have what? In many one you have, suppose like this, as you can see. So many one. So here the output, this output is linked with this element, say x1, and this element, say x2. But both of my x1 and x2 are distinct. Okay, but the output is same. I hope that it is clear. So this is many one. Okay. Okay. Let's move to next. Now onto function. Onto function or surjective function. So what do we mean by onto or surjective function? It says if every element of y means the element of codomain, okay, codomain. If every element of codomain is the image of some element of x under f. What this means? It means for every y belongs to y, there exists an element x in x such that fx is equals to y. Understood? No, let's understood by a pictorial representation. This is my A, this is my B set, or as given in statement x and y. This is my codomain set, codomain, and this is my domain set, domain. Now, say, so y1, y2, y3, y4, y5. Okay. Now let's associate them like this, 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 this. Okay. As you can see easily that it is a function. Okay. And is this onto? No. Because in onto function, the codomain set, in codomain set, every element must be associated to some element of x. As you can see, y5 and y4 are not image of any element in x. Yes, they are not associated. Yes, so not onto. So this means you cannot have elements just sitting there in codomain set, in onto set. In order to make this as onto, what do we need? Either you can remove them, then now it is onto. It is onto. Why? Because every element in codomain set, now my codomain is just y1, y2, y3. Yes, previously my codomain was y1, y2, y3, y4 and y5. But here my codomain is just 3 elements, y1, y2, y3, and all of these 3 elements are the image of some elements over here in the domain set. Yes, so if such happens, then this such functions we call them as onto functions. Okay, I hope that it is very clear to you. Okay. Okay, so that's what it is written over here. For any element in the domain, there exists an element x in the domain such that we can write fx is equals to y. As you can see, if this is my x1, x2, x3, x4. So for every element here, so pick any element, say y1. I can write y1 is equals to f of what? F of x1. I can write, yes, or I can also write it like this. Yes, yes, or and such thing must be happening for every element you pick in domain. So there exists x from the domain set such that f of x1 is equals to y1. There exists x for y2 such that f of f of x3 is equals to y2, and there exists x in the domain set such that y3 is equals to f of x4. As you can see, f of x4. Okay, I hope that it is now it is very clear to you that what happens in onto function. So from this you can say, what you can say, if you look that what is your range. If you recall, what is your range? Range is just nothing, the element which are set of all images. Range means range is equals to what? Set of all images. Yes, set of all images or set of all second elements in the ordered pair, yes. So if you try to make ordered pair, you will get what you will get as your range set. You will get y1, y2, y3, yes. So the other way to say that our function is onto or surjective is same as if you show that the range set is equals to the codomain set, yes, because every element must be an image of some element in the domain, yes. So this means the range set will be my whole codomain set. If this happens, then I will also say that my function is onto or surjective. So keep this point in mind. Okay, this will come in handy. Okay, let's move to next. Now, show that the function f from natural numbers to natural number given by this is 1 1 but not onto. Okay, so it is 1 1. Let's show. So to show 1 1, what we need to show 1 1. Okay, so given information is, so if you recall the 1 1 definition, what we have that if x1 is equals to f of x2, then x1 must be equals to x2. If this happens, then I can say that my function f is 1 1. Yes, so here this is my given thing and this is what I need to prove. So given information, always start the proof with given thing or the assumption. Assumption is fx1 is equals to fx2, and to show, what we need to show, that x1 is equals to x2. Okay, so now fx1 will be fx1, what it will be? It will be 2x1, and fx2, what it will be? It will be 2x2. From this I can say that 2x1 is equals to 2x2. From this what I can say, that dividing by 2 both side, what I will get? I will get x1 is equals to x2. So this means, what this means is, pick any x1 and x2, you will end up with x1 is equals to x2. So this means, what this means is that if x1 is equals to fx2, then x1 is equals to fx2. Sorry, if fx1 is equals to fx2, then x1 is equals to x2. So this implies our function is 1 1. So as we already given with that it is 1 1, now we proved it. Okay, now it is not onto. If it is not onto, what do we mean by not onto? Not onto means, okay, first of all, what do we mean by onto? So first of all, onto means I have the domain set, I have the domain set, I have the codomain set. Okay, domain set elements are like this and codomain set elements are like this. If my function is onto, this means every element in the codomain set must have some pre-image in the domain set. Yes, which means that every element must be linked to some elements. Okay, say like this. Okay, like this. This means onto. And now what do we mean by not onto? Not onto means, if you see domain set and codomain set, domain set and codomain set. Then what we have? We have some elements left over. What do we mean by leftover? This means in codomain set, we have at least an element which is not related to any element in the domain. As you can see over here, that this element is not related, not associated with any element, or it has no pre-image in the domain set. It is just sitting over here in the codomain set. So not onto means this. Okay. Now what? So if I have to prove that it is not onto, then it is same as to prove that there exists, let me first of all clear this thing. Okay. So so not onto means there exists and y belongs to the codomain set, which is this, our codomain set, which is n, codomain set n. Okay, there exists y which is belongs to the codomain set such that y cannot be written as fx. Okay, y cannot be written as equals to fx for any x belongs to the domain. So here domain is this set. So domain set. Okay, if I show this thing, then I can easily say that it is not onto. Okay, so I know, what I know is this, that if you take n and if you take such element that which is not written like this. So let's pick an element. Take 1. Okay, taking y is equals to 1 or 1 from the codomain set. Okay, now what? Can 1 written as fx? Fx, what we know is 2x, and x belongs to the natural number. Can this happen? 1 is equals to 2x and x is my natural number. Can this happen? Is there exist any x such that 2x is equals to 1? If you solve this, what you will get? You will get your answer as 1 by 2. If x is 1 by 2, then you will get your output as 1. Yes, but here x belongs to the natural number set. Here this is not from natural number set. So you found out an element from the codomain which cannot be written as fx. Okay, so this means that my function is not onto. Okay, I hope that it is very clear to you. Okay, let's move to next example or the. Okay, now I hope that the previous example was very clear to you. Now here my function is from R to R, means real number to real number, real to real. Okay, real to real. As you can see, which it is real function. In real function, the input and the output must be from real or real subset. Okay, input, the real function. Okay, now what? This is my domain. Yes, domain and this is my codomain. Okay. The function is defined just like previously. Fx is equals to 2x. Okay. Now we have to show that it is 1 as well as onto. Now we have to show that it is 1 as well as onto. The 1 is very simple. So for 1 the given information is the assumption is fx1 is equals to fx2. Okay. And this means 2x1 is equals to 2x2, and from this I can say that x1 is equals to x2. So indeed it is 1. Quite easy. We previously proved on the same steps. Now in previous example we saw that it was not what the onto function, but here it is saying that it is onto. So let's prove that. So in order to prove, to show onto, what we need? We need to show that range set is equals to the codomain set. Okay. And how are we going to find out the range set? Let's just follow my instructions. So first of all, to find out range sets, let's find out. So first of all, put fx is equals to y as my output. So y is my output. Okay. So this means y is equals to 2x. Okay. Now write x is equals to expression in y. Okay. What do I mean? I mean like this. So x is equals to some expression of y. Okay. So from this I can write, what I can write is x is equals to y upon 2. As you can see, x is equals to y upon 2. Now just try to see that what value can you put here. So what value can you put here? Are there any restriction over here? If you put any y value, no na. So this means you can put any y value. Any y value means, first of all, y comes from what set? Domain set. We know y is output, and set of all output is equals to what? Range. Yes, set of all output is equals to range. Okay. So now I have written x is equals to expression of y. As you can see, the y by 2. Are there any restriction? So if you put now a set of all output or the y values in here, all the y values will be in my range. Okay. So y comes from output, and output always comes from the codomain set. We know y belongs to codomain. Okay, y belongs to codomain. Okay. Now what? Now, and we also know that range set is also subset of what? Codomain. Yes. Now what? Now if you know that y is my output, and output is also always be from codomain, this means the collection of all y's will be the subset of codomain. Okay. And the collection of all such y, we called it as range. Okay. Now range is subset of codomain. We already know that. Now as you can see, and my codomain is what? Codomain is all real numbers. So this means range is a subset of real number set. Okay. Can you think any real number which cannot be apply over here? No. Any real number you can pick, you always get satisfy this thing. Yes. So from this I can say that the value for y, what I can apply, all real numbers I can apply over here. So this means y value can take all real numbers. So this means y, the collection of all y's is equals to, or the collection of all y's means range. Range is what my R, and R is what my codomain. So this means, what this means? This means that it is on to. Okay, I hope that it is clear. So let's look the other way by picture. If you draw the Cartesian on the Cartesian plane, the graph for this 2x, what you will get? You will get a line like this. And now for 1 1, for 1 1, for 1 1, for 1 1, okay, if you need to show that is my function is 1 1 or not, just draw a graph for it and do a horizontal line test. If the horizontal cuts 2 times the graph, then it is not 1 1. If it cuts only or exactly at one time everywhere, then it is 1 1. As you can see, it is 1 1. Yes, as you can see, it is 1 1. So it is 1 1. Horizontal test, horizontal line test. Okay, so this is my horizontal line test for 1 1. I hope that it is quite easy. If you recall that fx, the x square graph, what it's look like? It's look like upward parabola like this. Yes, if you draw a line, a horizontal line like this, you can see that it cuts 2 times. So this is not 1 1. Not 1 1. You can directly say that. Why? Because this, for this x and for this x, say this is my x1 and this is my x2. We know that x1 and x2 are not equal, but f of x1 is equals to f of x2. Yes, in 1 1 function this cannot happen, but this is happening, so this means not 1 1. So that's why the horizontal test is very important to quickly answer any 1 1 question. Okay, I hope you get the idea of horizontal line test. So that's it for today. Thank you. We will meet next time with more examples on 1 1 and on 2 functions. Thank you.